Let's talk about cross products. So I'm going to give you the definition of cross products, but I'm also going to show you some examples to make it easier to understand. Look at the definition at the top of the slide. Cross products are the products of the denominator of one ratio and the numerator of the other for a given pair of ratios. Ratios can be written as fractions. So when we're talking about cross products, we're talking about ratios that are written as fractions. So for example, cross products are when you have two fractions, and they can be equivalent, but they don't have to be. And let's say you have a fraction like 2/3, and you're trying to find out if it is equivalent to the fraction 6/9, and you're not sure. But what you can do is you can use cross products to determine whether these two ratios or fractions are equal to each other. And what that means is it says product of the denominator of one and the numerator of another. Okay, so get a different color here. So denominator here, 3, and the numerator of the other one times 6. Okay, so I would take 3 and multiply it times 6. That would give me 18. Let me grab a different color here. And then I'm going to take the other denominator and multiply it times the numerator of the other fraction. 9 times 2 is also 18. So what I would do is I would use those cross products to determine whether these two fractions were equal to each other or equivalent to each other. 18 equals 18, so 2/3 does equal 6/9. This carries me down to this next section. If ratios are equivalent, their cross products are equal. So what that means is if I have two fractions, and let's say there's a missing term. So let's say I have something like 1/2 equals n over 14. And I don't know what n is. Well, I do know, though, that if these two fractions are equal to each other, their cross products, just like this 18 equals 18, their cross products will also be equal. So let me fill in what would go here. Of course, I just got rid of all my annotations. Let me see if I can undo that. There we go. Okay, here we go. I think this will work. Okay, there we go. All right, so let me fill in what would actually go here. 7 would go here. So if two fractions are equivalent to each other, then their cross products are also equivalent. So I'm going to get a different color like I did a while ago. 2 times 7 is 14, and 14 times 1 is also 14. So their cross products will be equal, okay? And conversely, in other words, I just kind of turned this thing around and I said if the cross products are equal, then the ratios are also equivalent. So if I have two fractions and I know that their cross products are equal, that tells me that the fractions are equivalent to each other. So let's see another example. 1/3 and 6/18. And if I told you their cross products are both 18, then you would know that these fractions were equal to each other. This is going to come in more handy as we look at different problems that we want to solve using cross products. That's where cross products are very useful in math, is that if we have a sort of a proportional relationship problem and we have a missing number, we have a missing term, whether it's a numerator or a denominator, we can use cross products to solve the problem, so to find the solution to it. So let's look at an example. This says solve for u in this proportion. So I have u over 12 equals 1/3. So the important thing to note here is that they've told me these two things equal. Okay, so if they equal each other, that means their cross products are equal to each other. So let's think about this. So what I can do is I'm going to rewrite this over here. And of course, you already know what the answer is. I'm sure you've already looked at it and thought, okay, I already know what u is. But sometimes they're not as easy as this one. So we want to know how to use cross products. And sometimes we have more than just like a u up here. We might have a u plus 1 up here in higher level math. And so we want to definitely know that we can always use cross products to solve these sorts of problems. So what I would do is I would just take 12 times 1 and set that equal to 3 times u. Now, how do I write 3 times u? I would just write 3u, just like it was an x or an n or anything else. It's just a variable. 3 times u is 3u. And then, of course, I'm left with a one-step equation here. And what I would do to find out what the solution to this equation is I would just divide by 3 on both sides. And that will cancel. 3 divided by 3 is 1, so that leaves me with 1u. And 12 divided by 3 is 4. The other way to do it, of course, is say, okay, 3 times 4 is 12, 1 times 4 is 4, so u would have to be 4. Again, these are really simple problems, but the answer here again would be u equals 4. Let's look at another one. Solve for q. Now these numbers are a little bit bigger. The 800 is a little bit bigger than the one we had in the problem before, but it's still not too bad. Let's see, q over 800 equals 3 over 8. Now, sometimes it's easier, instead of solving using cross products, sometimes it's easier just to say, okay, look at the two denominators. I'm given the two denominators. So what do I have to do to 800 to get 8? Well, I'd have to divide by 100, right? So what number divided by 100 equals 3? Well, it's 300. So we know this is going to be 300. If we didn't want to do that, we could say q times 8, which is 8q, equals 800 times 3, that's 2,400, divide by 8. And hopefully you've done one-step equations before now, so you know how to do this. And q would equal 300. All right, let's look and see. We've got a couple of word problems before we finish up. Okay, so let's look at this one. And the biggest thing about word problems is you want to make sure you set it up correctly. Setting it up is like most of the battle, not even half the battle, but most of it. So Mara took a total of 4 quizzes over the course of 2 weeks. Okay, so there's my ratio. There's my first ratio. So 4 quizzes in 2 weeks. So let's just think about this. We're going to be asked how many quizzes will she have taken in 10 weeks. Okay. And then we're also told that it's proportional, which means the two fractions will equal each other. So let's think about this. I want to make sure that I put quizzes, let's say, in the numerator. And it wouldn't matter which way you did it. You just have to make sure all your fractions are the same. And let's put the number of weeks in the denominators. All right, so my first fraction is going to be 4 quizzes in 2 weeks. So that's going to be 4 over 2. And then I'm going to have another fraction. Okay, so the other one, 10 weeks, is my green number. So that's going to be the green one. And then what is going to be my pink number? What goes in the numerator over here? Well, it's asking me how many. And when you see the words how many or how much or whatever, something like that, that is your N or your X, whatever you want to call it, is fine. I usually put an N just for number. And then my green number here is 10. So the N and the 10 go together because it's how many quizzes in 10 weeks. And the 4 and the 2 go together because it was 4 quizzes in 2. I'm sorry, I said 2 weeks. I think I meant 10 weeks up here. 4 quizzes in 2 weeks. So we have 4 over 2 equals N over 10. And then we can use our cross products to solve this equation. 2 times N equals 4 times 10, which is 40. And 2 times N is 2N. Divide by 2 on both sides. N equals 20. So does that make sense? Well, let's see. 4 is 2 times 2, and 20 is 2 times 10. So yeah, that does make sense. It's a constant of proportionality of 2, so that makes sense. So it would be N equals 20, and that was quizzes. So 20 quizzes would be our answer. Let me put it up here too. Okay, let's look at another word problem. Dean wrote a total of 32 pages in 16 hours. How many hours will Dean have to spend writing this week in order to have written a total of 38 pages? So I have 2 different units of measure. One of them is pages, and the other one is hours. So I like to color code things. If you watch my videos a lot, you'll see that I like to color code and highlight things, so it's easier to get the numbers in the right places. Pages, okay, 32 pages. And how many hours? That was 16 hours. So that's my denominator here. And then the relationship is proportional, so they are equal. How many hours? Okay, so that is my green number. How many hours? So when we see how many, that is n. So that one's the green one, or the denominator. And then 38 pages goes here. All right, so this is one of those where, well, first of all, let me just say this. Remember that whatever you decide, we could have put hours over pages. It wouldn't matter as long as we had green all the way across the top and pink all the way across the bottom. We just have to make sure that the fractions that we write from the problem end up being the same, in the same order, so to speak. Okay, so this is one of those that I can't look at this and say, okay, 32 times something is 38. I really am going to have to use cross products to solve this problem, or I would have to simplify this first fraction and then look at it that way. But I'm just going to use cross products. I'm going to start with the one, you can either do 16 times 38 or you can do 32 times n. It really doesn't matter which one you start with. I always start with the one with the missing term. So I'm going to go ahead and start with 32 times n, 32n, only because I really like to have my variable on the left. That's just a personal preference. When I multiply 16 times 38, I get 608. Okay, I don't know off the top of my head what 608 divided by 32 is, but I'm going to put it in my calculator. So I'm dividing by 32 on both sides. N equals, and divided by 32, that is 19. So what does that tell me? It would take him 19 hours to read 38 pages. Well, that makes sense, doesn't it? Because 32 pages over 16 hours, 32, 16, and 38, 19. Well, 16's half of 32, 19's half of 38. That would be a constant of proportionality of 1/2. But the thing is, it depends on, okay, so if you do a graph, it actually depends on whether you put pages down here and hours over here. So if I did a graph like this, and I did pages to hours, that would be a constant of proportionality of 1/2. If I did it the other way around, I put hours down here and pages over here, it would be 2. So it really just depends on the graph and which axis you use for which type of term. None of that matters on this problem. We just needed to find out what n equaled. But just so you know, when we're talking about constant of proportionality, it depends on which one is the x and which one is the y. Okay, so 19 is our answer here, and we are at almost 13 minutes, so I'm going to stop here. Thank you for watching, and I'll see you next time.